Hi, it's Andrew Rowan here. This is my Hackfest entry for Kansasfest 2021. This is an idea I've been percolating on for quite some time, and I'm glad that this year I've actually managed to get some code written. Total Replay detects Mockingboard sound cards and configures the slot that it found the card in the code of all the games that use a Mockingboard. Some Mockingboard cards have speech capability. There are two different chips supported. Initially a Votrax SC01, which I just happen to have one of here, and later the SC02, or its more commonly referenced clone name of SSI263P. Several games are written that use one or other of these chips depending on how old the game is. Neither version works with all the games. The speech chips are rare and effectively unobtainium, so how can we all appreciate these games as they were originally intended? One way is to use an emulator. Some emulators support these chips, but not all do. And you'd need to configure the emulator correctly for the game you want to play, so you have to know in advance which games support which chip, and that really detracts from the browsing experience that we've come to enjoy from using Total Replay. And that doesn't give you a solution if you prefer to use real hardware. So that gives us an opportunity. The S.A.M speech card is more widely available secondhand, and the schematics are also available so people can make their own. If you don't want to build one, a version of S.A.M is available inside A2 Heaven's Mega Audio sound card. There's even a software implementation of S.A.M which uses the built-in Apple II speaker, so you don't need any additional hardware at all if you don't want to. So what if we can patch all the games in Total Replay that have speech to use S.A.M instead? So that's my idea. So what I've done. So last year I spent my Hackfest time disassembling the S.A.M software implementation to work out how to use it, because the readily available documentation is for the hardware version, but I didn't actually get any code written. So I'm using that as a reference. So this year I started writing some code to implement the idea. For testing purposes, I wrote two loaders to load the different versions of S.A.M into auxiliary memory. I chose to put S.A.M there because it's quite large, about 33 Protoss blocks, and it won't reside with the games that are running in main memory. And Total Replay itself doesn't have a lot of memory available, so putting it in auxiliary memory gets it out of the way of that as well. So this sort of means that this hack will run on machines with auxiliary memory, the 2E, 2C, 2GS. I wrote a small calling routine that has to sit in main memory that the game would use to get access to the S.A.M in the auxiliary memory, and a routine in auxiliary memory to load the selected phrase from each game's phrases into S.A.M's input buffer. Speak the phrase and then return control to the game in main memory afterwards. I'd like to shout out to Bobbi Manners for the Applecorn project. Source code provided some great reference material I could reuse for some of this effort. Thank you, Bobbi. I've been focusing my efforts this week on Jeremy Rand's Bejeweled game, which uses speech to give encouragement. I chose this game to start with because source code was available. However, as the source code's in C and the patch is in assembly, there's been a lot of disassembling going on this year too. I ended up with crafted patches for all the phrases used in the game, and I also wrote a small loader to install the patches into Bejeweled. Unfortunately, while the code works independently of the game, I've not yet managed to get the game working with the patches. Something's breaking during the speech output and I haven't figured out the problem yet. Going forward, the next step would be to understand where in each game they're invoking their speech and craft a patch for each phrase the game uses. I've started this process with Crime Wave. I've recreated all the phrases that are used in Crime Wave, so I'm well on the way with supporting that title, and the same thing needs to happen with the rest of them. What I've also done this week is I've actually built my own kit version of the S.A.M card. Unfortunately, I don't have it fully assembled, as I need a smaller drill bit to make some more mounting holes for the speaker jack that I wanted to install. But I've borrowed one from Jon Co for this demonstration. Thanks, Jon. So here's my Platinum 2E, and in there I've got a Jon Co card plugged in to slot 5, and CFFA card, and I'm not using the VidHD that's already in there as well. Here's my S.A.M card, which I haven't quite finished building, and here's my Mockingboard clone that doesn't actually have any speech chips at all. So the software, I've been using Jeremy Rand's Bejeweled image, and I've just added some S.A.M stuff that I've thrown onto the disk as well as I've developed it. So I'm using Bejeweled 2.6, which might not be the latest version, but the patch is quite easy to adjust when the time comes to adopt to a later version. So I've got a startup program that B-loads the auxiliary S.A.M version into main memory 2000, and then it calls the loader to load it into auxiliary memory. And I've also got a small patch for the game fixes for Bejeweled. I've loaded that into 8E1000 hex, which is above where Bejeweled loads, so that it can coexist. I've got the loader in memory at the moment. It's in 65C02, so that's why you've got some of these question mark opcodes. I'm really looking forward to Jeff Mazur and Dean Claxton's ROM XE, so I can put that in here and get a later ROM that decodes the opcodes so I can actually see them when I'm doing a disassembly. That'd be fantastic when that comes. Blatant plug. Anyway, so this code loads up the S.A.M into auxiliary memory, and then exits via a test routine to give it a whirl. So if you didn't understand that particular phrase, that was ready, which is one of the first ones that is used in the Bejeweled game. There are, the way I've implemented the hook into auxiliary memory is I start with an address of the phrase that I want to speak. The phrases are all in phoneme style, and they'd be all in auxiliary memory, ready to be used for whatever game that needs them. So each game patch would have the address of the phoneme that needed for that particular point in the game, and then it would jump to this routine. So we have to set up the stack and then jump through to auxiliary memory, and we play the sound and it comes back to main memory and RTS, so it's pretty clean. So that particular phrase is the one I've set up as a test after we've loaded the game, so I can just do that and play it again. If I want to set up a different, point it to a different phrase, I'm just going to change the address. So I'm just looking up in my source code output what address I can refer to as well. I've got some crime wave phrases loaded here, so let's go for 3.
Crime Wave 7.
And that was Crime Wave 7, if you didn't pick it up. So that's a demonstration of the actual sound coming out of the hardware version. As well, I've got a loader written for the speaker version, which doesn't actually require the hardware. That was the sound, or the phrase ready again. It uses the same interface. So it sounds a bit different with the software. That one didn't sound quite right. Maybe I need to go back and have a look at that. But yeah, anyway, the interface is common between the two different implementations of S.A.M. And the next step is to actually patch it into a game. As I said, I'll stick with the hardware one, because that seems to be
Ready.
Yeah, I can't show the patches running here. I've been doing it in the Applecorn emulator, but anyway, I know where to patch it. I've got the patches done. Yeah, like I said, I haven't got it completely working, so I'm not able to demonstrate that fully. If I did try and show you on Applecorn, it would just go to a break anyway, eventually. So what did I learn out of this week's effort? So I had to learn how to pass program execution control from main memory to auxiliary memory and back again. It's the first time I've used that. And also which soft switches were important for this is new to me. I had to learn how to use the Applecorn debugger for displaying auxiliary memory content, searching through memory for hex bytes, putting breakpoints in on memory read and execution, and setting the program counter, etc. I haven't used Applecorn's debugger before. Had to configure Applecorn's S.A.M emulation to work out how that worked. Got some more experience with the 6502 bench disassembler, and I learned that the Applecorn emulation of the S.A.M card sounds much better than real S.A.M card hardware. So if you're happy with emulation, stick with Applecorn. Anyway, future benefits of this potentially are, as my vision is that Total Replay games can use the S.A.M card. And also, potentially, Javier might appreciate a Total Replay version in Spanish. Anyway, have a great Kansasfest, and look forward to seeing you in person when we can. Bye.